David has 15 years experience in geostatistics, starting with Tenzing before his acquisition by Geovariances. Strong theoretical background in mathematics and physics, he has experience applying and teaching both introductory and advanced estimation and simulation techniques in various commodities. Other responsibilities related to software, where he has done tech support for Isatis, and probably you guys talk to him frequently, and Isatis New since 2014. More recently has contributed to development Isatis New, both testing as a user and doing some programming for the interface or calculation routine. So any problems, you can blame him. Please welcome David to the presentation.
All right, so Geovariances makes geostatistics software. The original Isatis was released in 1993, so we've had several decades of honing our algorithms and making calculations of variograms and Krieg estimates and simulations run quickly. And today's talk will be on Isatis.py, which is a new interface, Python-based, to those calculation algorithms. So we've been in the Datamine fold for a couple of years now. It'll be used by resource geologists primarily. And our main products today are Isatis Neo and Isatis.py. And while the subject of the talk is Isatis.py, I will spend one slide talking about Isatis Neo because that one sort of comes first chronologically and explains sort of where Isatis.py comes from. So Isatis Neo is a desktop application. So if you want to do your Krieg estimate, you do that by dragging things around with a mouse, typing numbers into text boxes, and then clicking on buttons. But you can record the buttons that you click on and what parameters you enter into scripts or batch files, as we call them. And in those batch files, you can put Python code. And this is what Boster was talking about in his previous talk. And I'm a huge fan of these batch files. I've done a lot of work on them, both as a user and as a developer. I think they're incredibly flexible and powerful. However, you can't do the whole thing in Python if you're using Isatis Neo. You can't just define a Python block and say, hey, I want a Krieg with this variogram model from my composites onto my block model, and that's what some people want. They want to be able to import Isatis into their sort of Python environment. So that's the motivation for Isatis.py. It's a Python library. It runs completely separately from Isatis Neo, so you do not need to have Isatis Neo installed to get the Python library running. This is a screenshot from VS Code in which there's a Jupyter notebook with some Python code, and like, I apologize to those of you who aren't familiar with Python. I probably just immediately started using words that you don't know what they mean, but that's kind of the that's the nature of giving a talk on a library used for a programming language. But while it is run independently from Isatis Neo, it's using the same underlying calculations. The compiled C++ code that is used in Isatis Neo and for the studio users, the same multi-threaded calculations used in CoKrieg are being used for Isatis.py. It's really just a Python interface to those underlying calculations. So why do some of our users want to go in this direction? One big one is it'll make scripts easier to read and maintain. Now, I am smuggling in an assumption there. My assumption is that you know how to use Python. If you don't know how to use Python, obviously, it's not going to be so easy to read and maintain it. But the good news is there is a large community of Python users out there today, and that has several advantages. One is there's an enormous amount of resources online to learn how to do Python. You know, Python for data science, Python for various applications. So you can learn about Python elsewhere. Of course, you know, I'm sure Geovariances will accept your money if you want us to train you in it. But you know, we're not going to pretend that we are the best at Python in an worldwide industry across many different sectors. Also, what it means is that, let's say you build your estimation workflows, you automate a lot of your routines in Python, and then the person who wrote them leaves the company. There's a huge applicant pool of people out there who are proficient in Python. They will be able to pick up the details of one library and then be able to understand what those scripts do and how to modify them in future. and they'll be able to do that faster than it would take someone who has never used a particular mining software package, and they have to learn where all the buttons are and where all the menus are and so forth. And one of the reasons why Python is so popular is because it is very extensible. There are many libraries, third-party libraries for scientific computing, data science, machine learning. So if the geostats is just one part of your workflow, you can slot it in sort of using tools that are purpose-built for this kind of development, and it should be relatively seamless. So let's have a quick look at some of the features that are in Isatis.py today. I'm not expecting you to memorize the syntax on the left-hand side of these slides. It's just designed to give you a bit of a taste of what it would involve. You're going to tell the software, hey, I'm going to run kriging soon. You tell it what the input data is, so your composites, you say what your output block model is, and you say call the kriging calculation with my variogram model and this ellipsoid parameters, and they would have had to have been defined earlier on, and the output is a kriged estimate. The graphics that you're seeing on these slides, they're very basic graphics. They're simple graphics. They're using Matplotlib, which is another third-party Python library. In a future release, you'll be able to stylize them so that you can make them a little bit more interesting. We're not going to pretend that the graphics in this presentation are amazing. You're not getting Isatis.py for the flashy graphics. You're getting it for the fast calculations for high-end geostatistics and the ability to automate them in the Python environment. Conditional simulations, a little bit more complicated. We now have to manage the Gaussian transforms as well. And again, that's a little bit hidden on this slide. You have to do all of the steps. It's not magic. The example in this slide is doing turning bands, but we also have support for sequential Gaussian and SPDE. Uniform conditioning. Here we're kriging onto wide space panels, but in the future we'll be making all waste classification decisions on SMUs, which are much smaller than the panels, and we would like to calculate grade tonnage curves on that future SMU basis. And so there would be a change of support needed to go from your histogram model on the point data to the SMU data, and we have the uniform conditioning calculator or algorithm that you can call, and the grade tonnage curves themselves are calculated in a couple of lines of Python. For categorical simulation, we have plurigaussian, which is what we're seeing on this slide, where you're able to control which domains come into contact with which other domains, and we also have sequential indicator supported. That was not a comprehensive list, but that's, to me, I think the most interesting of the sort of the big ticket geostats items. We also have basic data processing, so you can import your collar survey assay files, composite, do declustering, etc. Upcoming features. The big one for our existing Isatis Neo user base is the ability to use Isatis Neo projects as an input and output from the Isatis.py calculations. As I said, at the moment, it runs completely independently, and usually, and I apologize again for name-dropping Python libraries, those of you who've done Python and data science, you'll be familiar with the pandas library to import CSVs into a data frame. And that's how we'll be doing most of our work in Isatis.py today. Eventually, once we can talk to Isatis Neo project databases, then it becomes a big open question. Maybe a lot of our existing users start switching to writing their scripts in Isatis.py, working directly with their Isatis Neo projects, so that the parts of the workflow that they want to use the mouse and the graphical user interface, so things like variography, for example, and the validation, the 3D viewer, that can be done more seamlessly and integrated with the Isatis.py scripts. All of the example features that I showed earlier were sort of core geostatistics. It's a geostatistical calculation involving a variogram model and input data and output data. We don't have all of the little utility tools that aren't sort of pure geostats. For those of you who've used Isatis, I'm talking about things in the data management menu, things like migration and copy statistics. So they're on the roadmap. If you're looking at this and you're thinking, wow, this is amazing, but I'm not going to use it if it doesn't have reblocking, there are ways to do the reblocking directly in Python. So there are workarounds for these particular features at the moment today. But it would be nicer if we have if you could just directly call these reblocking functions from within the Isatis.py library, and that's on the roadmap. We also have use of faults in the Kriging neighborhood, so you truncate your search ellipsoid when you hit a wireframe surface. Other features that will be coming up will be dependent on user demand. We've got a few early adopters of this, and they're pushing it pretty hard. The sort of people who are enthusiastically using a new Python library are pretty switched on Python users. They are pushing it to its limits, finding out what it can and can't do, giving us the feedback of what we need to do to make it better. I'll be seeing many of you tomorrow in the workshop being led by Roberto Rollo, and you'll have, if you can install it on your computer, a couple of weeks to test with that. If you use it longer term and give us your feedback, you'll be able to help shape the future development of Isatis.py. Thank you.
Why Python and not something like R?
Yeah, good question. It's almost certainly just coming from the fact that Python is popular elsewhere, and so we'll follow that trend. I would say I've used both, and if you want to import data from CSV, filter it, run regressions, R is just light years ahead of Python. It's not even close. The Pandas data frame is a very poor imitation of the R data frame. But for everything else, I do prefer Python. I think the syntax is more elegant. And just because it's so much more popular, there's more resources for it. We'll follow that crowd. They both work. If we put it all into R, it'd function the same. It's still the compiled C++ under the hood.